Hello everyone. As you know that I am doing fluid mechanics previous year question. So this question from Unique Services examination, I am also dealing the question of GATE or civil services. So today topic is hydrostatic forces. I have already completed one part. So this is part 2 of hydrostatic forces from the Unique Services examination questions. This is about myself. Okay. So if you have not watched the previous videos, please watch those videos as well. Anyway, we'll see today's questions. Okay, see, this question is a little bit complicated. Okay, so this diagram is given. Okay, so let's read that in the figures. Situation shown in the given figure, the length BC is 3 meter and M is the midpoint. Okay, M is the midpoint. This they are talking about. This is midpoint of BC, the hydrostatic force on BC. Okay, the hydrostatic force on BC measured per unit width being perpendicular to the plane of the paper with G being acceleration due to gravity will be. So they are asking actually the what is hydrostatic forces on this BC. Okay, this BC. And yeah, so and these are the options. Anyway, this is not required. So actually see in this question actually horizontal and vertical, both the forces will act. Okay, so we have to take net of that, then only we'll get the complete hydrostatic force on this BC. Okay, so let's see that how to solve this question. Okay, anyway, this height is given 4, BC is given 3, this angle is given 60. Okay, this angle is given 60, and gravity is given. This is the only thing is given, rest thing we have to assume and we have to solve this question. Okay, anyway, we'll see. Fine. Okay, so this is the question. Okay, I have put it again here. So okay, anyway, so I think this is completely no, fine. So this is okay, this is given what 3, this BC is given 3, so we can get this length. Okay, we can get this length, so this length, like so we'll get 1.5. so this length will get 1.5. okay, so this total will be 5.5 because 4 plus 1.5, so this will get 1.5. and similarly we'll get this also. You can just use sine 60 cos 60, you can just resolve, so you'll get this horizontal and vertical component. So vertical component will be 3 root 3 by 2. So this simple geometry you can do here. So anyway, I told you, so on BC the total net resultant force will be root of FV plus FH square. So horizontal and vertical, both the forces will act. So we have to calculate both the forces, horizontal and vertical, then only we can get the net force. So first we have to calculate the vertical force. So vertical force is nothing but it is like weight. So vertical force is nothing but it is weight of the fluid. Okay, and horizontal force is nothing but it is hydrostatic forces. Okay, so the weight is nothing but rho gv, that is nothing but rho gv. Okay, so v is what, area into x bar. Okay, so the x bar will be, we have seen in the previous videos we have seen that. Okay, so 4 plus h1 plus h2 by 2. Okay, so this is highest, largest and least. So 4 plus 5.5 by 2, and so this will be this also required for area. Okay, so like 3 into root 3 by 2. Okay, and 10 to the power 3 rho gh. Okay, so rho is what, 1000, and g, so if you simplify this whole thing you'll get vertical force. So this is nothing but 12.34 into 10 to the power 3 g Newton per meter. Okay, so they are actually calculating Newton per meter, so you have to multiply with this into 1, so you will get per meter. Okay, now we have to calculate the horizontal forces. So horizontal force is what? It is like hydrostatic forces, so which is nothing but rho g ax bar again. Okay, so this projected area on BC, that is BT into depth of the center of BT into 10 to the power 6 G. Okay, so this will be 1.5 4.7 into 10 to the power 3 G. So if you simplify this, you will get 7.125 into 10 to the power 3 G. So this is nothing but horizontal force, and this is nothing but vertical force. Now take the net of these two. Okay, so if you simplify, you will get this. So 1425 G Newton per meter. So its answer will be D. You can see here D. See, actually I don't know why they have asked this question in engineering services, because in engineering services calculator is not allowed. Okay, so like this question you can expect in actually in GATE examination, because there is calculator is required. You can see in a lot of calculation is there. Without calculation you cannot solve this kind of question. Okay, without calculator you cannot solve this kind of question anyway, but they have asked. So what you do, if you are finding this kind of question in the exam, and if you are feeling like a lot of calculation is there, so you skip this question, do other question, and in the last, if you are getting time, then only you solve this kind of question. Okay, this question actually is a simple question, but it's a lot of calculation is required. You can see here, very clearly you can see with this calculations. So please avoid this type of question. So in the last, if you're getting more time, then only you come back to this question and solve it. Okay. Next question. A circular annular plate bounded by two concentric circle of diameter 1.2 and 0.8 meter is immersed in water with its plane, making an angle of 45 degree with the horizontal. The center of circles is 1.625 below the free surface. What is the total pressure force? What will be the total pressure force on the face of the plate? Okay, so they are asking what is the total pressure force on the face of the plate. So these are the options. You'll see that. Okay, so is nothing but is like hydrostatic force. Okay, so it's like they are giving diameter, concentric diameter, it's 1.2 and 0.8. So it is like rho g ax bar. Just remember rho g ax bar. So area is what? Pi by 4 d square. So here like two diameters concentric is given. So what you do, like area is pi by 4 d1 square minus d2 square. So like 1000 g pi by 4 1.2 whole square minus 1.2 square minus 0.8 square. Okay, and x bar, you know that how to like is given already 1.625. So that we have to put here, you will get 10 kilonewton. So the answer is B. Simple, straightforward, formula based question. Next question. Consider the following statement about hydrostatic forces on submerged surface. Let's see that it remains the same even when the surface is turned. It acts vertical even when the surface is turned. Okay, it remains same even when the surface is turned. It acts vertical when surface is turned. So consider the following about hydrostatic forces on the submerged body. Okay, see, it remains same when the surface is turned. Okay, first is correct. It acts vertical even when surface turned. No, this is wrong. Okay, it's vertical. No, this is wrong. Okay, so the only first is correct. So the answer is A. Next question. Okay, so this is given. Cylinder is given. This its diameter is given. Okay, so what? It's submerged. A cylindrical gate. This gate actually is holding water. Okay, so this side is the water, and this is the cylindrical gate. It's shown in figure. The resultant vertical component of force of water per meter width gate will be. Okay, so they're asking vertical component of force of water per meter depth of the gate will be. So these are the options. Okay, let's see that. So what is the vertical force? Okay, we have seen in the previous question it is nothing but weight of the fluid of half of the cylindrical portion. Okay, so that is actually the weight of the liquid. Okay, I mean vertical force. So vertical component of force is nothing but weight of the liquid for half of the portion of the cylinder. So that is what is rho gv. This weight is what rho gv. You can see here rho gv. So we have to write the volume pi by 4 d square into L by 2. Okay, because it's saying half of the cylindrical portion, so its area is pi by 4 d square, and volume is what, like, we have to multiply with the L by 2, so pi by 4 d square into L by 2 into rho g. So L is given 1, okay, and G is 1000, and this rho is 1000, G is 9.8. So if you simplify this, you will get 15409.5 Newton per meter. Okay, so answer is C. Next question. The vertical component of force on curved surface submerged in a static liquid is equal to. Okay, let's see the option. Mass of liquid above the curved surface, weight of the liquid above the curved surface, product of pressure at Cg, or you can say okay, multiplied by the area curved surface. Okay, the product of the pressure at Cg multiplied by the projected area of the curved surface. Okay, so the vertical component of force on curved surface submerged in the static liquid is equal to. Okay, so is actually, okay, so it will be weight. Okay, जहाँ पे weight दिखा, that is the answer. So answer is B, weight of the liquid above vertical surface. Okay, so the correct option is B, since the vertical component of force on curved surface submerged in static liquid is the weight of the liquid above the curved surface. So the answer is B. As simple as that. Okay, next question. The depth of the center of pressure for rectangular lamina immersed vertically in water up to the height h will be h is given by. Okay, so these are the options: h by 2, h by 4, 2h by 3, 3h by 2. Okay, so these kind of question actually when I will teach the complete lecture series of fluid mechanics, so there I will derive how this is coming. Okay, so here like they are asking directly the formula. So once I will teach these things, I will do that. Okay, so it is actually C 2h by 3. As of now, you just remember this. So once I will come up with the series of fluid mechanics complete lecture series, you can watch there. Okay, I have already started now already uploaded 3 to 4 videos. Okay, so it will continue in course of time. Next question. The point of application of horizontal force on curved surface submerged in liquid is. So okay, so like they are asking again the formula. These are the 4 formulas. So A is the area, H is the depth, G is the moment of inertia about the center of gravity, CG. Okay, so I think you know this formula very very well if you have already studied the hydrostatic forces. So I'm expecting you know this formula. So it is actually B IG AH square by H bar. Okay, इसमें sin theta भी आता है, we'll see that later. So IG plus AH square by AH bar. So it is actually B. Yes, in this it is coming. Okay, so what is the vertical distance of center of pressure below the center of plane? Okay, so these are the options. So actually C IG sin square theta by AH bar. Okay, IG sin square theta AH bar. So please remember this formula. Next question, again the similar kind of question is repeating anywhere. What is the depth of the center of pressure of vertical immersed surface from the free surface liquid equal to? Okay, so these are the options. So I think you can easily answer the question. So it is actually A Ig by AH plus H bar. Okay, fine. Okay, so this was the end of the part 2 of engineering services question. So I will come up with the more question of engineering services in the coming videos. Thank you for watching. Bye bye.